All right, chapter 15, part 3. Here we're going to talk about entropy in the second law. So, change in entropy is heat divided by temperature, a reversible process. And if the process is irreversible, we have the same change in entropy. Entropy is a measure of how much energy is not available to do work. So even though all forms of energy are interconvertible and all can be used to do work, it's not always possible, even in principle, to convert the entire available energy to work. In other words, there's always some energy lost somewhere in some way, almost always. And that unavailable energy is of interest in thermodynamics because the field of thermodynamics, as I said earlier, arose from efforts to convert heat to work during the Industrial Revolution. And they're really looking at how do we maximize the amount of work we get out of the heat we're generating. Entropy always increases, but for a Carnot cycle, the heat flowing in from the cold reservoir divided by the temperature of the cold reservoir equals the heat flowing in from the hot reservoir divided by the temperature of the hot reservoir. All right. So the change in entropy is just Q over T for delta S, which leads to the work unavailable is delta S divided by times T0, where T0 is the lowest temperature used. All right. So simple formulas. Work unavailable is the change in energy Q over T, reversible process, times the lowest temperature used. Over time, complex organisms evolved from much simpler ancestors, and so that represents a decrease in entropy of the Earth's biosphere. It is, in fact, that living organisms have evolved to be highly structured and much lower in entropy than the substances in which they grow. But it is always possible for the entropy of one part of the universe to decrease, provided the total change in entropy of the universe increases. In equation form, we write this as total entropy change is the entropy of the system, change in entropy of the system, plus the change in entropy of the environment. And that always has to be greater than zero. But the entropy of the system we're looking at can be negative as long as the change in entropy for the environment is both positive and greater. Okay, that's our last little bit on entropy in the second law, and this is it for chapter 15.